Let's look at some examples where we have rational exponents. Let's look at x raised to the 2/3 power is equal to 4. There are a couple of different ways of solving this. Probably the most straightforward way of solving this, and probably the easiest way to solve this, would actually be to raise each side to the power of that denominator. Get rid of the denominator first, because if you try to do anything with that numerator, you may miss something. So get rid of the denominator by raising each side to that power, and then we can look at the rest of the problem. Because when we raise each side to that power, that will leave us with x squared is equal to a 64, because raising 4 to the 3rd power will give us 64. Now, as I solve, I will take the square root of both sides, and when I do, I have to remember the positive and negative square root of the 64. And so that will give me x is equal to a positive negative 8. If I try to x raised to the 2/3 is equal to 4, some like to raise things to the inverse, which would be the 3/2 power. And you can do that, but you have to remember, if you raise things to the 3/2 power, if you have a even number on this denominator, you have to remember to put a plus or minus sign in front. And this is something that probably gets forgotten most of the time. On the left side, that's no big deal because that just becomes an x. On the right side, that does become an issue. We have to remember that that's a positive or negative 4 raised to the 3/2. You can actually do that in your calculator. That will still give you a plus or minus 8. But a lot of people tend to forget that plus and minus. So I would probably recommend that you raise it to the denominator first and then take the square root. Now in this case, both solutions do check out. So our solution set is a positive negative 8 in this case. I also want to look at a situation in which we have two radicals. Let's look at 1 minus a 2x is equal to a 2 plus the square root of 1 minus x. So we have two radicals here. On the left side, this radical is already isolated. So I can actually go ahead and raise both sides to the square, to the 2nd power. On the left side, I'm strictly going to get 1 minus 2x. On the right side, I have to be careful because these two things don't cancel out. I have to remember that this is 2 plus the square root of 1 minus x times 2 plus the square root of 1 minus x. And I have to multiply. So 2 times 2 will give me 4. 2 times the square root of 1 minus x will actually give me a 2 square root of 1 minus x. Square root of 1 minus x times 2 will give me another to square root of 1 minus x. And then square root of 1 minus x times square root of 1 minus x will give me square root of 1 minus x squared. I'm going to simplify this right side. These two items can combine to give me 4 times the square root of 1 minus x. This simplifies by the square and the square root disappearing or canceling out. So that gives me plus of 1 minus x. And so 4 plus 1 will give me 5. And I'm going to go ahead and move that minus x to the front so that I don't get it confused. Plus a 4 times square root of 1 minus x. 1 minus 2x. I'm going to notice I still have a radical, so I need to move everything to the left side now. So I'll subtract 5 and I'll add an x. And so I get negative 4 minus x is equal to 4 over the square root of 1 minus x. Now, before I mentioned, and I'm going to bring this down so that I can see it a little bit better. Before I'd mentioned dividing out this 4 to get the radical by itself. But if I divide by 4, this ends up with a nice number, but this one does not. So I'll show you what happens if you don't divide and you square both sides, because it can be done. On this side, okay, it gets squared. So negative 4 times negative 4 will give me a positive 16. Negative 4 times a negative x will give you a positive 4x, another positive 4x, and an positive x squared. Over here, think of this as 4 squared and this squared. So that's 4 times 4, which is 16, and I don't need the square root. I need times a 1 minus x, because they're multiplied. Each item will get squared. So I get 16 minus 16x. And then over here I get an x squared plus 8x plus 16. I'll add 16x to both sides. And I will subtract a 16 to move everything to one side. So I'll get x squared plus 24x is equal to 0. I'll factor out an x. So I'll get x times x plus 24. So I get x is equal to 0 and x is equal to a negative 24. And when you check both of those back up here in the original equation, only one of these will work. And that one that works will be the negative 24. So this one is a much longer process because we had two radicals and one of them had a plus and minus. So we actually had to do the process twice. So be careful with those items and make sure that you don't just cancel this radical with this square, because you have this plus and minus sign here.